why you need IoT security. I'll talk about the pieces and parts, the components, uh, how it integrates with Prisma Access, and then we're going to do the same thing with DLP, data leakage protection, and how it integrates with Prisma Access. We will then have a Q&A session at the end. So if you have questions, there is a Q&A function within the webinar. So you can post your questions and we can answer them if we have time at the end of the session. If not, we can follow up offline and talk to you about that. But as opposed to using the chat function or raising your hand, that Q&A function be what you want to do. So why do we need IoT security? The Internet of Things, card swipers, security cameras, if you work in a hospital environment, things like smart devices for IV tubes and things like that. Why do you need that? Well, it's because those things are vulnerable. And in most cases, those devices don't have admin accounts or logins or things like that. Like you can't normally log into your camera, your DSLR camera, to be able to secure it and lock it down. Oh, and they're vulnerable if they're online. You can't necessarily log into your smart doorbell that takes pictures and stuff like that, like Blink or anything like that. And those devices have internet access. And if you have devices that have internet access that you can't control, you don't know what they're doing. Traditionally, the problem is you don't know what they're doing. You can't see these IoT devices. You can't control them. You can't log into them. You can't do any sort of control of them. So you have limited visibility into them. No protection. There's no way to stop your doorbell, your smart doorbell or your thermostat from calling back to China every 10 seconds or things like that it does. You can't stop it from recording pictures. You can't stop your doorbell from recording pictures of who comes to your door and reporting it back to the company that owns it or anything like that. That's just not possible. So there's no protection for these things. And if there is some sort of protection, you got to do it yourself. You got to change your network infrastructure. You got to isolate these IP addresses. You have to do these things by IP address, not by device or not by use case or things like that. So it's very difficult to isolate and control and protect these IoT devices. We take a different approach. The idea here is that we categorize these devices, saying, what are they? Is this a doorbell? Is this a security camera? Is this a IV drip machine in the hospital? Is this a DSLR camera? Is this a smartphone? Is this an iPad? Whatever the device is. And we categorize and understand what those IoT devices are. And then we assign risk levels based on experience and based on machine learning and AI and all this experience we have, and say, hey, what are the risks of this device? This device is my thermostat. And so, the risk level might be kind of low. The worst thing it can do is turn off my air conditioning or allow the government to turn off my air conditioning when I need it. However, if it's a security camera that's protecting a bank vault, well, that could be a pretty high risk if somebody can remotely turn that off. So we assess the risks of the device type after we understand what it is. And then we automatically create or do create and send recommendations to you and say, these are policies, these are security policy rules, these are things you should do to mitigate that risk. Just like we prevent threats to computers and users and devices on your network for known threats, for viruses and things like that, we can do that with your IoT devices also. And just like we do with wildfire for users and laptops and computers, where we use machine learning and artificial intelligence to respond to unknown threats, stuff that nobody's seen before. We do that with IoT devices also. So if you think about how we do user ID with users on a network and create rules and limitations and access for different users, it's the same idea with devices. So device ID and IoT protection is a lot like user ID. But now we're looking at devices instead of users. We're not looking at Bob connecting on his laptop. We're looking at the laptop itself. So the idea is that we have the ability to identify these devices and different types of devices. And it takes a day or two to do that, usually about 48 hours, because not every device is online every moment of every day. If I connect with my iPad into Palo Alto networks, maybe I do that once a week. Maybe I do it once a day. My laptop, however, is pretty much constantly connected. So we need a little bit of time to look at those things that aren't connected all the time. And usually about 48 hours or so allows us to see about 90% of the devices. We constantly monitor to find new devices. So if you're using a card swiper and business hours are 9 a.m. to 5 p.m., and you connect us at 10 p.m., well, it's going to be 9 a.m. the next day. It's going to be 11 hours before we see that or people start using it. So you have to give us a little time, but we constantly monitor all of these devices, wait for them to connect. We look at multiple different attributes, multiple different components and behaviors of devices. Are they connecting locally to a network? Are they connected to the internet when we didn't know they were? Are they reaching out to foreign governments and reporting data and things like that? Those are all the things we look at. There's about 50 different attributes we look at. We look at these behaviors and these devices and give them a risk score. And we have the ability to automatically prioritize these different devices and behaviors and bring them to your attention based on their risk levels and based upon their behavior and based upon how many devices they are and things like that. So we look at changes in their behavior. We look at their outbound and inbound connections. We look for vendor advisories or vulnerabilities. You know how if you have a car and there's a recall on your car that says, well, the brakes don't work, or the emergency brake doesn't work, or my car catches on fire if I plug it in my garage at night. Well, you want to know about that. So different vulnerabilities and advisories are where we keep track of that for you. We give a risk level that we assign arbitrarily, and you can change to all of these things, just like we do with our app ID stuff, right? So app ID, we identify an application, we give it a risk level, we say, well, this is a risky application to use, or it's safe. Well, you can change that risk level. Same thing with devices. You could say, well, my online thermostat, you assigned it a risk level of 3. I think it's maybe 2, whatever you think. And then we give you policies. We feed you policies that say, you know what, based upon this device and its behavior, there's some things that you're allowing it to do that maybe we don't want to do, or maybe we do. If it's calling back to the Chinese government or something like that, and taking pictures of everybody that, if it's a security camera, taking pictures of everybody that enters a building or leaves a building, and using that for facial recognition to a hostile government, and maybe we don't want to do that. So we give you rules that are our suggestions that you could use. So we profile these devices. We identify these devices, which then allows you to do ZTNAs, zero trust networking, and say, well, put these devices in this group and these other devices in another group. Suggest rules that say, I want to allow this or deny that based on security policy rules. We also take care of all of the known vulnerabilities and known viruses and things like that that can affect these devices with our antivirus protections and all of our threat protections. And this is all done, this categorizing categorization of devices, rules for these different categories, allows and denies for these different categories, threat protections for these different devices. It's all done automatically. Now you have the ability to see these rules, these suggestions, and say, yeah, I'd like to implement that, or no, I don't want to implement that, but it's all provided to you. You don't have to write this stuff. We just tell you, hey, we think this is what you should do, and you say yes or no. So we have the ability to prevent these known threats, right? Malware, spyware, exploits, all those sort of things that use signatures, command and control, and calling back home, and all these sort of things that you would typically think of users or user devices for. So all of our known threats are protected. Unknown threats, right? So inline wildfire, and AI and machine learning on hardware devices and software firewalls, sending stuff we've never seen before up to wildfire. so that once somebody sees it and we block it, everybody's protected from it. And our connection with XOR and all of our other pieces on our platform allows you to detect and respond to these unknown threats that, I mean, it's really easy to protect for known threats, which is about 20 to 40% of what's out there. But what about that other 60 to 80%, that 0-day stuff? Well, we can protect your devices from that just like we can your users with user ID. How does this all work? Well, let's take a look. So the idea is that we have Prisma Access, our SPNs, our RNSPNs, and our MUSPNs, which are like gateways, and all of our different security processing nodes that you can think of as a firewall in the sky, right? Just as though you had a firewall inside your house or inside this remote office or inside or protecting this mobile user, Prisma Access gives you that. So how PAN-OS, whether it's Prisma Access or a physical firewall, identifies these devices as it looks for them logging on to the network. When you install a smart thermometer in your house or a Ring doorbell or whatever, it connects typically using DHCP. Says, hey, I'm a new device, I need an IP address. It connects to your router at home. That's the same thing at work, but written large. So we need to see that DHCP connection, the request, the reply, and then we can tie that IP address back to a device, just like we tie an IP address of a user back to a user. Now we're doing a device instead. And we have a cloud-based directory of devices. And we say, hey, you know what? This doorbell or this thermometer or this security camera has these sort of vulnerabilities or these behaviors that are normal, or you may see this stuff which is not normal. And we have this dictionary of stuff. Once we identify your devices, we say, hey, these are rules that we think you should deploy. We also then have the ability to send logs and metadata to our cloud-based IoT security engine. And that's how we get ongoing information about the behavior of devices. And if the behavior changes, we're like, hey, you know, this was safe, now it's no longer safe. It was behaving one way and now it's behaving differently. So as things change and devices get updated and different companies integrate with other companies and have different ideas as to what sort of personal data they want to share and what sort of information they think is fair. You can control those devices and say, no, I don't want to do that. Yes, I do want to do that. Maybe you take that back to TikTok and you think about all the users on TikTok and all their videos and all their user information and all their geolocations and stuff like that is being shared with a government overseas. And you may think that's okay, or you may think it's a bad idea. So we can help you write the rules to say, yeah, that's okay, or no, I don't want to do that. So between the logging that you have to enable to say, find these devices, tell me what kind of devices they are and categorize them. Give me their MAC addresses, their IP addresses, show me their connections, and let me look at their HTTP connections and stuff like that, as well as their DHCP requests, and identify them. We now have the ability to identify these devices we've never seen before. And go, oh, this is new. This company is using a new security camera we've never seen before from this new provider we've never seen before. We can report that information into the cloud and go, hey, Palo Alto Networks, what is this device and what are its vulnerabilities based on what it is? We can look that up for you. We can look for anomalies and say, well, all of a sudden this device is starting to call back home and send videos that it sees from the security camera that it never did that before. It's all of a sudden doing it now. So we can detect these anomalies. And then we can make security policy rules and recommendations and tell you, we think you should do this. We think you should block that from happening. It's up to you to say yes or no, but we make the idea. How do we do this? It's based upon information we see. And one of the pieces of information is the DHCP options. When devices try to connect and get an IP address. Also, user ID or device ID information, very similar to our user ID information. The different protocols that are being used, is this HTTP or DNS or what sort of protocols? And we look at the headers. Let me give you an example here. When a device connects with DHCP to a DHCP server, well, there are many different options it does. It's saying, this is my MAC address and I need an IP address, and I'm this sort of device. And if you look at the middle of the slide, option 55, there, the parameter request list, gives you all kinds of information. This discovery information is useful to us to identify what sort of device it is. Is this a laptop or an iPad or a security camera or a Alexa? What is this thing? And based on what this thing is, what's the normal behavior and what's not normal? We use this information, this not specific information about your device, but the type of device, this metadata. Oops. And we say, this behavior is normal for this device. It may be weird for another device. The way my security camera runs is different than the way my Alexa or my Google Assistant runs. And their callbacks to home or back to Amazon or back to China or whatever it is, maybe normal, or maybe it isn't. It may be acceptable to you. It may not be acceptable to you. You make these decisions. We give you optional rules that you can deploy. To do this with Prisma Access, you have to enable logging um, to the data lake, which you do anyway. That's how we log everything: traffic logs, security logs, all that stuff. And you have to enable this enhanced application logging. It's turned on by default, but you got to make sure nobody turned it off. Without the enhanced application logging, we cannot do IoT protection. We then have to have security policy rules to allow these DHCP interactions to take place, but we have to have rules to log it, right? So you have a security policy rule that says, let this happen and block this other stuff. If you don't have a security policy rule that matches specific traffic, one of two things is going to happen. Either it's going to hit the default intrazone rule that says block it and it won't work, or it's going to hit the the automatically created intrazone. So interzone, between zones, is going to be blocked. Intrazone, within the zone, is going to be allowed, but we don't log it. So if you don't have an explicit security policy rule, we can't see this stuff. So if you want to see what devices are making DHCP requests and we're allowing to go online and stuff like that, you probably need intrazone rules within a single zone. You need to allow and be able to match and log these DHCP requests so that we can see them. We can do our device ID and determine what sort of device it is and what sort of rules we think you should use. So you need to create these intrazone security policy rules with allows, send those to Cortex Data Lake so we can see them, and now we can tell you what to do. You, of course, have to forward these logs to Cortex Data Lake. So in the log forwarding profile, which, again, if you're using Prisma Access, you're already doing this, or you should be forwarding all of your logs, and you need to do that. So that little black square there says enable enhanced application logging to Cortex Data Lake. Make sure you have that turned on. And throw all your logs up there. Whether they're enhanced application logins, whether they're URL logs, whether they're threat logs, whether device logs, configuration auditing, send everything up there. Decryption logs, all of that. So this allows us to do a lot of things, right? We have the ability to understand what the device is. We have a whole list of devices. We can go, oh, this is a camera, this is a doorbell, this is a smart thermostat, and we can define it with our device dictionary. We can also take that DHCP request, map it back to an IP address like we do with user ID, or say, well, Bob has this IP address right now. We say, well, your Ring doorbell has this IP address right now. And then we have the ability to create rules, security policy rules and other policy rules that we suggest to you, but you have the ability to say, yeah, I like this, or no, I do not like that. So I want to implement this or not. As I said, the device dictionary defines what the device is and what type of device it is. Is it a smart doorbell? Is it a security camera? Who made it? Samsung or HP or whatever. What model is it? Is it 2 years old, 4 years old? Is it the newest model? Is it an old model? What OS is it running? Is it running Linux? Is it running something else? BDS or whatever it might be. And what version is it running? Is it running some old obscure version of FreeDB that's very vulnerable, or Linux is very vulnerable, or is it running some proprietary operating system? So is it new or old? So what version is it running? The second piece is mapping that device to an address, saying, right now, my card swiper that's at the front door of my office has IP address, 172.16.1.1. It has this MAC address. It has this host name. It is a security camera, not a thermostat. It was made by this vendor, it's this model. And we assign a risk score and a risk level and say, you know what, this thing's safe to use or it's risky to use. All of that is part of the IP to device mapping. So the first thing we do is we see a device, we see it log on, we go, oh, this is the device it is. Then we do all of our mapping, just like we sort of do with user ID mapping. We do this with devices. And then we give you the rules. We say, based on this kind of device, this is normal behavior you should allow. This is abnormal behavior that you should block. And that's how those three pieces kind of work together. The next thing I want to talk about is DLP, data leakage protection. Hey, how do we keep information from being leaked out? How do I protect my social security numbers or my credit card numbers or that sort of thing? Just like we do that with our hardware firewalls, it's available with Prisma Access. So I have users, I have devices, I have users using devices to reach applications up in the cloud, whether they're sanctioned applications that you as a customer want to allow your users to access, like, I don't know, Salesforce or Workday or whatever. Unsanctioned stuff that users do, they go check their Twitter feed or whatever they do and say, well, yeah, it's not an official application, but we don't care. Users do that. And all their information that's stored up in the cloud, in Azure or Google Cloud or Amazon or, Office 365, all those sort of things. You need to protect that data and allow or deny it, to allow normal behavior and block risky behavior and protect the users. If somebody's trying to hack into your employee files that live in Google Cloud, you got to be able to protect that stuff. If I have a user that's using their private email and gets a link that says, hey, I'm your bank and you need to click here and reset your password, it's probably a phishing email. Do I want to protect that user when they're using their own private, unsanctioned SaaS applications? Maybe yes, maybe no. These are decisions you have to make. So with everything moving to the cloud and nothing on site anymore, now you have to make these decisions. What is allowable and what's not allowable? And what do I want to protect and what don't I want to protect? PII, personally identifiable information, intellectual property, confidential information from my company, using sanctioned apps or even unsanctioned ones. What if I'm sitting at home on my laptop and decide I want to email 1,000 credit card numbers to somebody on 4chan or something to use, but I'm not using my company email. I'm on my laptop using my own personal email. Is that something I want to know about? Is that something I want to stop? Something I want to control? Those sort of things are the things you have to think about when you're talking about cloud-based stuff. Also, regulatory stuff, GDPR. What information is allowed to be gathered and what isn't, and that depends on where in the world you are. Other compliance and regulatory agencies, PCI compliance, HIPAA compliance for healthcare information, stuff like that. All those sort of things you have to think about. And again, this stuff is no longer in your network. It's all up in the cloud. I got to protect it somehow. User behavior. We're just talking about devices. What about the users using those devices? What about my example of deciding to email 1,000 users, 1,000 customers credit card numbers to some anonymous person on the internet? Is that something I want to do? Do I want to allow that behavior or not? So all these things are important when you're talking about protecting data. And now, unlike you did 20 years ago, you have to understand where is my data? Where is this information? The answer used to be, well, it's in a server inside my data center, right? It's not that. That's not true anymore. It could be in the cloud. It could be on Amazon. It could be on Google Cloud. It could be on one of my vendors' websites that uses the cloud that I didn't know about. How's this data being used? We're talking about TikTok earlier. How is this data being used? Well, we're doing facial recognition so we can recognize people. We're collecting information about every single place they go and every single application they use and every single phone call they make and every single text they do. And how's that being used? Well, ask China. I don't know. And how do you protect that? Well, the answer would be, without knowing where the data is and who's collecting it and how it's being used, I can't protect it, but now we can. And that's what we want to do with DLP, is define what information is sensitive and protect it. Well, in the old days, you used user-defined text strings or pattern matching that you as a customer, as a user, would have to define. So you'd have to determine, how do I define a legitimate credit card number versus just a random 16 character long uh, pattern? And how do I define which ones are credit cards, which ones aren't? How do I define what a driver's license looks like, or a credit card number, or a passport number, or things like that? So you would have to do that. You would have to make sure the information you're trying to protect is sent to the device, the DLP device that you need it to do. And something that's not on here actually was it is probably encrypted. So you need a device to decrypt that. And most DLP devices don't decrypt. So you need another third-party device like a firewall or a load balancer or something like that to decrypt that information, so that the out-of-line DLP device can see that information, or it's blind. It's really expensive too, right? So I got another piece of hardware or more. Usually these DLP devices have low throughputs, and if they have onboard decryption, that reduces their throughput by like 95%. So you need a lot of them. You need, they're siloed, they're out of path. You need to send that stuff there. And somebody's got to watch this stuff. What is allowable? What's not? Bank account numbers. If I want to see those, social security numbers, credit card numbers, that stuff I want to hide or obscure or overwrite or just allow. How about internal documents that are stamped as do not share, or confidential, or proprietary, or top secret, or whatever? I gotta let your DLP device know what's okay and what's not. Which of your vendors can do this, and can they do it for all of these things, or do I need multiple vendors? So you may need a lot of products, a lot of different licenses. The devices traditionally have always had to be on site, and somebody's got to manage them. So you need a dedicated team. And when you catch this stuff, you need a team, you need resources to understand what you're trying to protect. When things happen, are they false positives or true positives? They got to comb through all these alerts. It's tough stuff. It requires a lot of time, a lot of resources, a lot of people, a lot of money. But if you want to do PCI compliance, well, you got to do this. If you want to take credit card payments, it's something you got to do. So you got to think about this. So what we do with DLP is we automatically look at everything going through your network and discover what sort of data, what sort of sensitive data is going, whether it's going up to the cloud or staying on your internal network stuff. Is it east-west traffic, north-south? Yeah, we look at the type of data, discover it, monitor it, understand how it's used, and protect it. Blocking it or allowing it, maybe just east-west internal communication, but not out to the internet. The direction, the type of information, what the information is, all of that goes into this. Well, we have a cloud-based service for this that works with Prisma Access and our physical next generation firewalls, or VM firewalls, Prisma Cloud, our SASE security, all those sort of things. It's the same service that can protect all of these devices on our platform. And we can give you the rules and suggestions for all of these devices on our platform. So you don't need 5 different divisions protecting 5 different types of devices, end users and firewalls and cloud-based stuff. It's all one team that can do all of this, because the idea is that whether it's a physical device or a virtual device, it's the same technology. As long as we see the data, it's data in motion. We then have the ability to discover, monitor, and protect this data, just like we did devices earlier. Now it's the data passed by these devices, irregardless of what type of device it is. So we have our DLP service, and our devices send this information, this metadata, not credit card numbers and stuff like that, but just patterns and stuff like that, up to our DLP server. It classifies that data and says, well, this looks like a bank account number or a credit card number or a passport number or something that's important, or you know what, it's just a random series of numbers. It's somebody's bank account balance, that we don't care what that number is. Send that to our DLP service. They can then say, well, you know what, this is something we should erase or protect or block or allow internally but not externally. So we have the ability to do all of those things. You should let your people do that. You should tell them not to do that. So we have the ability to notify. We have the ability to quarantine stuff. We'd say, you know what, somebody tried to send out an Excel spreadsheet with 10,000 credit card numbers, and we blocked it and we quarantined it. And we're not going to let that happen. We're going to prevent it. And we can tell you what the device was, who the user was, when they did it, all of that information. So the who, what, when, where, why that you also want to know, between IoT information, device information, user information, the data type, data linkage protection, right? We fill that all up together and give you the entire picture. And it's simple to integrate. Basically, under the Panorama tab, if you're Panorama managed, and if you're using the cloud-based management, there's the configuration menu there also, which I'm sorry I don't have a picture of. You say, yeah, I want to send this information up to the cloud. I want to enable DLP. And that's really it. And then it goes, do you really want to do DLP? And you say, yes, I do. Sends that stuff up to the cloud, sends it to Cortex Satellite, sends it to the DLP engine. Any information going through Prisma Access is going to be inspected. Any on-prem information, if you have on-prem firewalls, right? Think of Prisma Access like a firewall in the cloud. All the things that your onboard firewall can do, Prisma Access can do, or vice versa. So yeah, we can do it for both. We can compile that information. We then have the ability to look at all kinds of stuff. So if you look at the Prisma Access information on the slide. We have about 850 different patterns we can look at, and in fact, it grows every day. For all I know, it could be well over 1,000 now. Different profile types and actions. Alert on this stuff, allow this stuff, don't report it, block this sort of stuff. Many different applications. People, putting credit card information into Amazon on their phone. People trying to take internal top secret documents and send them on their send them on Hotmail or whatever the case may be. Yeah, we can do that. Lots of different applications. About 20, over 20, a couple of dozen different file types that would be types that would transport this sensitive information. We have the ability to do all that. If you look at that top line, we use machine learning. We go, not only is this something already known, but does this sound fishy? Let's make an instant decision. Let's use AI. Let's use machine learning. The file type, the file properties, snippets allow us to have pre-created rules that we can use with a confidence level that says, yes, seems really risky to us, or this is not very risky. We have levels from 1 to 5, and the ability to create custom patterns. Maybe what my bank uses as a bank account number is different from what your bank uses as a bank account number. Maybe mine's 9 digits and yours is 7 digits. We can create custom patterns to define these sort of things. So we can define these patterns, the behavior, the user behavior, have an action to allow or deny based upon the applications, based upon the file types. And if we tie this back to IoT, based on the device. So the user, the application, and the device. I mean, you can't get more secure than that. You can't, who gives you more information? So that's how we protect your digital way of life now and in the future. All right, so folks, we have